Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial, we started our journey on the Dynamic World Dataset, and we created our first dynamic land use land cover image or layer for our region of interest. In our case, we narrowed it down to August 2015. Okay, so we generated, let's call it a 3D land use land cover image for our region of interest for 2015. And remember, we set the 3D element, or the dynamic element of the image is where we created a probability distribution, and we converted that probability distribution into a dynamic number that we then allocate to the height or elevation for a particular region. So that creates the 3D element to it, and that's basically what we ended up. We ended up with a nice looking land use land cover image for our region of interest, as I said. And if we or each any area in our region of interest will have a probability distribution, which basically is the allocation of the classes, or the categorization of the different classes. Remember, there's 9 classes or categories of land cover, and that is now the population distribution that we allocate for each location within our region of interest, and that determines the height or the elevation of a particular area. So this is what we ended up. Remember, there's our script, and I said the script is all based of all this work is based on our 2 sources, or our 2 references, which is the community tutorials within Earth Engine, and then the Gandhi work in this particular website. Okay, so we're just basically using what they've done. Okay, so the next one, well, as I said, this is an image that we've created for 2015, and specifically for 08, for August of 2015. That's the first image for that particular period. So that in general will also be then the first image for our region of interest, because the time period, if you go to the landing page of the Dynamic World Dataset, is only from the 6th of the 15th. So that will anyway be our first image. Okay, so as I said, let's continue with our journey. And in this particular case, what we want to do is we want to create 2 images. Let's call it, let me go slowly through it, let's call it a pre and a post. I've just used pre and post. Again, you are welcome to use any names or abbreviations or references. That's totally up to you. So what I've basically done here, or done here, is to say, okay, I want to create 2 images. And that's it. I call it a pre and a post. I want to create the image for 2015, and I want to create the image for 2023. So I'm going to create 2 images. In my case, a pre and a post. A pre image refers to the 2015 image, and a post image refers to the 2023 image. So now I've got 2 images. I've got a land use land cover image for 2015, and I've got a land use land cover image for 2023. So I want to compare these 2 visually to identify areas where the land use land cover has changed. Call it change detection. Okay, so I want to create 2 images so I can generate or visualize temporal change detection. Okay, so that's basically what I want to do. So to do that, I need obviously 2 images. Now, in my case, I can't go earlier than 2015, because, as I said, that's when the Dynamic World Dataset starts. It starts at 2015. So that's what I have as my pre-period, the first image. Then my post period, I used August. Well, since the image 2023 image is August, it makes sense to make the post image also an August image. No point making it a, let's say, a February image or a March image or even a December image, because the land cover would be substantially different from August, simply because of rainfall, harvesting, agriculture, and so forth, and sun direction, all sorts of things. So to compare apples with apples, a pre and a post, I use the same month, August to August. Now, if you're going to use December 2015, use December 2023. So always use the same month, but obviously different time periods. Okay, so that's why I've got the month exactly the same. So the only difference is August. Now, remember, you cannot have two variables with the same name. So in this case, start date, and here is start date 1. I could have made it pre and post, should have, for consistency, but be that it is. There's my pre-dates, time frame, and there's my post dates or post time frames. And I said I've made it 1 and 1. Okay, and to distinguish, so there's a start date in the start. If I didn't make that and it was start date and start date, Earth Engine would obviously use the first one, which is 2015. So your stuff would be all screwed up. So please remember, never ever two variables of the same name. Use some thing to distinguish between the two variables. In my case, I use pre and post. Okay, so there is my, as I said, pre variable. Okay, so I've called it pre, and it's based on this start date and end date. Okay, table 3 is my region of interest, 35 degree, 35%, less than 35% cloud cover. Okay, you see there's my post image, and that's based on the dates 1. Okay, those two dates. So this is my pre-period, which is 2015. This is my post-period, which is 2023. And I've labeled them, or called them pre and post. Okay, so the visualization parameter for both of them will be exactly the same. You can make it different, but they're exactly the same, because it's the same image, just different time frame, the same band, same everything. Then you'll see I'm going to generate the first image for 2015, first image for August 2015, and I'm going to generate the first image for August 2023. And I'm calling it pre and post. Then I'm going to add those two first images to my map. Okay, pre and post. I'm using the same visualization parameter. I'm calling it 2015 and 2013. Okay, so it's not going to display because I've got a swipe. I've got a dual images. So in fact, I should basically just it's not going to show it anyway. Okay, so then I do the same thing. I'm going to match now. I generate an image, a unique identifier or ID for each of those two images, and then I'm going to match it in my Dynamic World Dataset. Okay, so there's the pre-image. You can see 2015, 10th of the 8th month, 10 August 2015. See, there's my post, 1st of August 2023. Okay, so it's the same month, basically 9 days apart, so the chances there would be significant, let's call it natural changes in land cover, would be slim. Except if it was the one year was extreme drought and the other year was extreme wet, then obviously there would be differences. So just bear this in mind, that there could be natural differences. That's why you want to use the same month roughly. Okay, and there's the matching. It's matched it now to those images. So it matched it now to those images in my Dynamic World Dataset. Okay, so you see there's 2015 0810, 2015 0810 2023 080, 23 080. So now I've matched it. Okay, so there's the matches. Generates a unique value or ID. It goes to the dynamic database and it searches for that ID, and then it matches that ID, and then it calls up that Dynamic World Dataset. Okay, so that's basically what's happening here. Then we are classifying our Sentinel pre and Sentinel post image based on that Google dynamic world datasets. We're classifying it, and we call it a pre-classification image and a post-classification. The pre is set just 2015 classification, and 2023 classification. Okay, and that's going to. So in fact, I should do this as well. They're not going to display if I take out, or if I excludes the split panel option, then obviously you have to activate that, and then the layers will display. But with a split panel, it will automatically ignores all layers except those one that we're going to use in the split panel. Okay. Probability bands for both images are exactly the same. Okay. So water, trees, grass, etc. Green, I can't remember. Remember to go to the dynamic world. There's the bands and there's the colors. Okay. Maybe you can get those information. Then we are generating the probabilities. Okay, because remember, within dynamic world, all these categories or classes are estimated probabilities. Okay, estimated probabilities. So we're generating the probabilities, and then we're allocating that probabilities to our elevation. Remember, the elevation is based on the yield side. Okay, so yield side calculates the elevation in meters from sea level. So we're converting that height, that elevation, basically swapping that or changing that with the probability distribution. And that's what we're doing there, and then we just add them, and that's why I divided by the 255, etc., etc. And then we just then going to display those maps. Okay, so remember, this is an important step here. As I said, what we're doing is we want to create a height or a 3D element to it, which is typically your height. So we're generating the elevation in meters of that location, and we say, okay, rather than to use that height or that elevation value, let's replace that with a probability distribution value. Okay, and that becomes then the elevation or the height or the 3D element. Okay, so that's basically what we're doing there. Okay, and again, if you're not sure, you don't understand it, please refer to the tutorial in Earth Engine. That will give you the methodology clearer than what I can do. Yeah, so that's what we're basically doing there, and then we are displaying it. But as I said, what I'm going to do is I'm not going to display them as separate images, which you can, but then you have to select, deselect, select, deselect, select, deselect, which is visually not that great. So I'm creating a split panel. Okay, so I'm creating a split panel. Remember, on my left hand side, there's my first image. That would be my pre-image, or the 2015 image. That will be on my left hand side. Okay, let me just make it a bit bigger. Yeah, so that would be on my left hand side. So that's the pre-image. See that? That's the pre-image. Be on my left hand side on my panel, and then the second image on my right hand side will be the post. You see, there's the pre will be on my left hand side, the post image will be on my right hand side, and then I'm just creating my split panel, and I'm just remembered, yeah, so that's important. You set, so in my script initially I deactivate my map center here, and I'm basically creating a map center within my split panel options. Okay, so I'm just copying and pasting that in there. There's my zoom level. Okay, remember, the higher this, the more you zoom in, the smaller, the more you zoom out. Okay, so I just deactivate the map center here in the beginning where I normally do it, and I just basically center it here, because now it's centering it around my split panel. Okay, so here, so all that's new from this to this is I'm creating a split panel, which is basically, so I'm still adding the two images, the pre and the post image. I'm just adding them within a split panel option. Okay, so that just makes the visualization much easier. Okay, so let's have a look at it. So just make it a bit bigger, and you can see. So there's my 2015 image. Okay, move it all the way to the left. There's my 2015 image, and there's my 2023 image on the right hand side. Okay, so you can see now. Let's split them, move them over, and you can see. First of all, have a look at this side here. Slowly, that piece of land here, location there. You can see that's 2015. Pretty much nothing. A little bit there. Remember, red is built up or urban. There's a little bit there. There's a little bit there. But if you move to 2023, you can see that area, how that is built up. And I think we've displayed that in our open buildings video tutorials as well. Seaside properties that has been developed here from the about 2019, 2020, when it really started to kick off. You can see a little bit of movement. Have a look there. That side there, there's a bit of movement there. You can see there's some 2015. You can see in general 2015 seemed to be much drier here. You can see much less vegetation, more shrubs and bare soils and things. You look at 2023, much wetter, and that's correct. 2023 we had much above average water, way above the average rainfall that we've received. Okay, we've looked at the river itself. The river seems fairly, nothing much changed with the river. The river seems fairly constant, but you can clearly see significant change in the built-up area, especially around this area here, and obviously the vegetation has become much more green. So that seems to be the predominant changes that have occurred. In this particular area, the built-up have stayed fairly constant, nothing too much. A little bit of, if we look at there, a little bit of changes there, but nothing much. So it's predominantly a bit of build up there, and then natural changes because of the above average rainfall. But in general, so that gives you quite a nice visualization of nice change detection visualization between these two periods. Now, I can obviously do that for any region of interest. So let's say I want to do, let's say, let's go this down here. So I'm just going to import it. Remember, I've loaded this asset, the shape file for this particular asset. I'm just going to import it. So it's going to be called table. So now I just need to make sure that I do all my changes within my code to reflect the table. Let's see, there, I must change it there to table, I must change it there to table. Any place else where I need to make changes? Let's have a look and see. I don't think so. It's only those couple of places that I had to make the changes. Nope, all looks good. Okay, so let's press run. Okay, obviously I didn't send them, so there's no 2015. You can see there's no 2015 image for that area, for that specific town. There's a 2023 image. Okay, so let's make this now. Let's increase our search period to include up to the 12. Let's press run again. Let's see. So it's in the 9th. Okay, so here what we're going to do is we're going to change this to the 9th, just to make sure that our periods are exactly aligned. Okay, so let's make that 09, 09. Okay, so let's run it again. Let's see, make sure 09, 09. So roughly the same time periods. 22 September 2015, 5 of September 2023. So that's not too different. That's exactly the same. Now obviously that town is a little bit, it's not close to my region of interest. So let's zoom in, and it should be, I don't know, there it is. Let's zoom in there. That's the town of Friedenthal there. Let's go in. Okay, so I'm gonna keep it like that. Let's wait. Okay, it's starting to load. Make it bigger. Let's just give it a couple of seconds while it's loading. Guys, remember, on the left hand side, it's the pre-images, which is 2015. On your right hand side, it is the images for 2023. So why is the images for 2023 not loading? Let's have a look and see. So is there no images for 2023? There must be an images for 2023. Maybe not. Why is 2023 images not loading? There's definitely not a 2023 image. That's it has identified a 2023 image, but it's not showing identity. So let's make it 2022 and see if that works. That is unfortunately trial and error, because you simply don't know. Because yeah, now I detected 2022. Let's have a look and see. Otherwise, it's got to do with the split screen. Let's have a look and see now. Okay, so it's loading the 2020. Okay. Loading, it's loading. Okay, why is it struggling? Okay, so it doesn't wanna. Okay, so there is a problem here. Let's have a look and see where is the problem. Okay, so I need to generate a split screen. Let's go and get that map center there, because it's now centered still in our previous town. So let's just replace it there. And then, okay, so it should open. Okay, perfect. It's opening there. Let's have a look and see. Just wait for the script to load. Okay, it doesn't want to load the 2023. It's got an image, but it doesn't want to load a 2023 image. As you can see, it loads a part of a 2023 image. So what this now basically means, I'll show you now, is that the satellite image, the Sentinel image, is different. Okay, so yeah. So let's look at a different town. Let's call Vredenburg. Let's see, and we're going to import that one. Let's see if it does the same for this one. So let's call that table 2. Table 2. Let's remember to make that table 2. Table 2. I think that's the only places we're going to run. Oopsie. We're going to go to the town of Vredenburg. Where's Vredenburg? There it's located there. See if it works. It should work. That has to do with the underlying Sentinel image that is not projecting correctly. Doing the same here. That's interesting. This is the 2 images for the town of Vredenburg. Let's just maybe activate the satellite view. So this is the town of Vredenburg, which is also part, as I said, within my assets. There it sits. Okay, so remember the left-hand is 2015, or what I call pre, and the right-hand side is 2023, or what I call post. Now, the reason why the images didn't want to show, specifically the 2023 images, is just because of the times or the dates. So when you have a specific location and it's presenting correctly, the pre and the post image, and you go to a different town, don't simply assume that the images will be exactly the same, because they may be different Sentinel images for that specific region of interest. So this was the case here. So I had to change my dates to the 10th of the 15th, to the 10th of the 23rd. The 09 images for this town didn't want to display properly. So I just amended my time. The code, there's nothing wrong. So if we have a look at this town, you can see nothing significant change in terms of the urban areas. You can see that there's 2015, there's something there, and there it is there. But in terms of, you can see there's a bit of expansion there. You can see that. But in terms of the other specific locations, there's a bit of expansion there. You can see there. You can see there's nothing there. And also a little bit more green water. You can see there's some water there where there's not there. So, but in that town. So let's quickly go back to that other town I didn't want to show called Vredendal, which is just table. So let's just move that to table. Let's make that table as well. I'm not going to change the central positions. Let's make that table. And let's make that table. I think that's the only places where we make the table changes. I'm going to keep that. Let's just run. Let's see if that dates work. I'm going to just zoom out so I can go into that town itself, looking for the town. There it is. Let's see if that works now. Yep, that seems to, yeah. So it doesn't, so the 9th month in 2023 don't seem to have any images. So we just changed it to 10th. So when I've determined that the 9th month does have an image, I then obviously changed the beginning period also to reflect the 9th month. Okay, so that was basically why it didn't want to work, because of the 9th month. Okay, so let's have a look. So there we go. You can see very little water here. Okay, it's still loading. Should be done now, but you can see that the rain, significant water in 2023. In terms of the urban areas, that looks fairly similar. Some changes there, some changes there, but in general. But you can see the big thing between the two periods is the level of water. You can see 2023, and as I said, 2023 has been way above average rainfall. 2015 was again a particular dry year, so that's why there's quite a lot of change in the natural vegetation or agriculture of the land cover. Okay, so yeah, so just bear in mind, interesting enough, good that we've done it. It is to do with the images. So if your images don't display correctly for some not for whatever reason, but if it doesn't display, most probably the issue lies within this dates. So just go and play around with these dates, and it would work. Okay, and so what we've done here in this tutorial is we're creating a pre-image or beginning 2015. We created a post-image 2023. When we created a split screen so that we can display these two images, so that we can visually detect any change in land cover that has occurred between these periods. Okay, so yeah, obviously this is now again static in that you have two, let's call it static periods, a 2015 period, 2023 period, which may or may not be a true reflection of the change. But anyway, more work to be done in future tutorials, future video tutorials, but that gives you a nice visually to detect any land cover change that may or may not have happened within your region of interest. Okay, well, yeah, there now, yeah, interesting. It's now and again we have to run into difficulties or problems, because together we'll figure it out, and then we better for it than if we didn't run into these problems. So all problems are good in that it is solvable. That's the important thing. It has to be solved. It cannot be a problem forever. And as I said, we figured this one out. Okay, yeah, thanks. Thanks for staying with me. Thanks for joining me on this journey. Remember again to like and subscribe and to share this video. And I look forward to having you on board in my future video tutorials. And thank you, and stay tuned, and I'll see you on the other side.